Greetings and good day. First of all, I'd like to thanks to conference organizers and secretary for their outstanding efforts in making this event possible. Welcome to my presentation. Today I'll be delivering a presentation with the title Biochemical Effect of Live Fish Transports. This presentation will focus on the biochemical effects of transporting live fish. Process of live fish transportation encompasses a complex interplay of factors that extend far beyond the just physical relocation of fish. In this review, we focus on important factors to consider to increase the success and animal welfare of live fish transfers. Live fish transfers are critical in aquaculture and can be made more efficient with careful planning and good practices. Open system transport vessels with oxygen connection are used in commercial fish transfer operation. As you see, there is fish loading process from cage to transfer tank, but there is air exposure here. For example, as you see, fish loading to cage nets and taking from cage to transfer tanks and then exposure air here. The pivotal moment during this transfer processes is the exposure of fish to air during loading, recognized as the most stressful event in the transportation of salmonids. What is stress or stress factor? The physical response of the organism as a result of the intervention of external or internal factor is called stress, and the stressor is called a stress factor or stressor. To reduce the effects of stress and improve animal welfare, it's recommended to minimize the duration of exposure to air and avoid exposing fish to supersaturated and suboptimal dissolved oxygen levels. Transporting fish from farm to outlet, transferring to a new cage, scaling exposure to air, loading, transportation, and unloading are all stressful for fish. In a study conducted by Iverson et al. In 2005, it was shown that fish loading procedures are more stressful than the transportation itself. The process of loading fish into tanks before their transfer represents a physically demanding task for both aquaculturists and the fish themselves. The environmental factors affecting trout are routine farm practices, environmental pollution, and seasonal factors, all of which can be considered as stressor for fishes. Farm practices cause changes in parameters such as oxidative index, glucose, and cortisol as a result of the excitement they cause in fish. Fish weight and water temperature are important factors underlying the oxygen consumption of fish in relation to oxygen metabolism during transportation. The increase in water temperature in transport tanks increases the need for oxygen. In terms of fish transportation, for every 0.5 degrees increase in temperature, the stocking density in the tank should be reduced by about 5.6%. Conversely, for every 0.5 decreases in temperature, the load can be increased by about 5.6%. Oxygen. The amount of oxygen a fish consumes also depends on the amount of oxygen available. At high levels, the fish will consume at a constant rate. When water oxygen levels are low, fish consume a lower amount of oxygen than when oxygen levels are high, despite the degree of activity. When dissolved oxygen in the water is lower than needed, this is known as hypoxia. Water without oxygen is called anoxic and it's lethal to fish. Hyperoxia, on the other hand, provides too much oxygen, and while this doesn't threaten to limit aerobic ATP production as hypoxia does, hyperoxia can affect a wide range of physiological and biochemical function in fishes. Carbon dioxide, pH, and ammonia, high carbon dioxide concentrations are harmful to fish and are limiting factors for transfer. Carbon dioxide, a product of fish and bacterial respiration, acidifies the transport water. Although this reduces the percentage of non-ionized ammonia in the water, it also reduces the oxygen carrying capacity of fish blood. Although oxygen levels are apparently sufficient, fish can die if carbon dioxide levels are high. Cortisol, an increase in plasma cortisol levels is expected to be common in all stressors. Studies have shown that plasma cortisol levels in fish, as in other vertebrates, are recognized as the main determinant of stress. In general, glucose is required by all body cells as a continuous energy source and must be maintained at adequate levels in plasma. Perchin and Konyaloğlu, 2008, reported in a study that glucose in blood serum may be one of the best indicators of stress in fish. Depending on transfer condition, fish show extreme effort and a large amount of muscle activity. When muscles are actively used, there is not enough blood to meet their needs. An alternative system comes into use where energy is provided in the absence of normal amounts of oxygen. Lactic acid accumulates in the muscles and blood and causes the pH of the blood to drop. Oxygen utilization is reduced by the low pH of blood. After a few minutes of strenuous muscle activity, lactic acid accumulation may not decrease for 24 hours. In many studies, it has been reported that lipid peroxidation formation in blood and tissues starts with the increase in serum MDA malondialdehyde level due to stress in fish after transplantation. When the stress caused by live fish procedures in fishes is evaluated biochemically, it causes an increase in plasma cortisol and glucose levels, as markers, and a decrease in antioxidant capacity due to lipid peroxidation. Stress can be minimized by following good handling procedures. Proper design and operation of transport tanks and oxygenation system can reduce many fish stresses. Proper water quality is important to maintain fish health and reduce stress during transportation and adaptation to the water which they will be transported. Thank you for listening to me.